Hello and hi, we are from Group 9, Argon Laboratory Sundan Berhad, Energy for Tomorrow. So before we begin our video presentation, we would like to introduce ourselves. Hello and hi, I am Vyashni Mohan with matrix number 198900.
My name is Muhammad Alif Iqmal bin Zulkafli. My matrix number 198978.
My name is Afifah binti Muhammad Arshad and my matrix number is 198776.
So we would like to begin our video presentation. So this is our block flow diagram. So it begins with an isothermal compressor, followed by ASU and OCM, amine absorber, dryer, demagnetizer, deatomizer, C2 splitter, and ends with condenser. So the first unit would be the isothermal compressor. So the temperature for the inlet and outlet is constant, which is 25 degrees Celsius, but the pressure is only changes. So we will consider work shaft as our Q. So the Q would be 10676.79. So the second unit would be ASU, which is air separation unit. So if you look at this, the temperature and pressure for each stream is constant and same. So which means there is no energy balance for this unit. Because ASU contains multiple unit inside itself which regulates its own temperature and pressure. So the third unit would be isothermal compressor. So again, the temperature would be the constant, but only the pressure will change from 5.26 bar to 11.9 bar. So the Q will be 4980.62 kilowatt, and this is work shaft as well. So and then followed by the heater. So for here the temperature changes from 25 degrees Celsius to 365.72 degrees Celsius, and the pressure remains constant. So we would be considering the heat as the energy. So the Q will be 2492.7 kilowatt. So and then it is also followed by isothermal compressor again. So the temperature remains constant and the pressure changes from 1.01 bar to 11.9 bar. Again, we consider work shaft and the Q would be 2157.538 kilowatt. And then followed by heater. So for heater, the temperature will change from 25 degrees Celsius to 365.7 degrees Celsius. Meanwhile, the pressure remains constant, and the Q would be 12,895 kilowatt. And this, the heat is absorbed, which is an endothermic reaction. And the OCM, which is oxidative coupling method unit, would be the reactive reactor for the whole ethylene production of our company. So for here there would be three streams, and the temperature for this inlet streams, stream 9 and stream 6 is the same, which is 365.7 degrees Celsius with the pressure 11.9 bar. But the outlet pressure and temperature differs, where the temperature would be 600 degrees Celsius and the pressure would be 10 bar. So when we will do the normal energy balance calculation, and the resulting Q is negative 70,725 kilowatt. This negative indicates that the heat lost to the surrounding, which this is an exothermic reaction.
So I will continue with the cooler. The main purpose of this cooler is to lower the temperature. So the inlet temperature is 60 Celsius and the outlet temperature is 40 Celsius. The pressure of this cooler remain constant. So the energy is negative to 28,600 kilowatt. So next is isothermal compressor. This isothermal compressor is the temperature is constant while the pressure increase from 9.86 atm to 10.86 atm. So the Q will, when we do the energy balance calculation, the Q will be 8.593 kilowatt. So next is carbon dioxide removal. Um, for the amine absorber, the inlet temperature is 10.86 atm, and the inlet temperature is 40 Celsius. So
So we continue with the dryer, which is in this unit we are constant the pressure outlet and the inlet, and we are focusing on the change in temperature, which is the outlet. The temperature for the outlet is 313 Kelvin, and the inlet, which is 303 Kelvin. The purpose of this change in temperature is we need to separate between the other compound and the water. So the next one is we start with the first distillation column, which is demethanizer. Okay, this is the value of the mole flow rate and the temperature inlet, which is 40 degrees Celsius, and the pressure, which is 26,252 and then for the outlet, which is 5 degrees Celsius, and the pressure is decreased at the vapor streams, which is 19,000 mmHg. And for the liquid vapor, you can see that the temperature, which is negative 17.1 degrees Celsius, and the pressure is 4,050. And the Q for the demethanizer is, which is negative 5.99 and the power of 5 kilowatt. So for the deethanizer, the temperature inlet is 5 degrees Celsius and the pressure is 12670.2 mmHg. And for the vapor streams, the temperature is negative 28 degrees Celsius and the pressure is 1 bar, only 1 bar. And for the liquid stream, which is stream 22, the mole flow rate is 587.84 kmol per hour, and the temperature is 108 degrees Celsius, and the pressure is 12773.6 mmHg. And the heat release was negative 1.66 and power of 3 kilowatt. So for the next distillation column, which is C2 splitter, the temperature inlet is negative 28 degrees Celsius and the pressure is constant, same as uh, same as streams before C2 splitter, which is deethanizer, which is 750 mmHg, and the vapor streams, we can see it. The temperature is negative 8.26 degrees Celsius and the pressure is stay at 750 mmHg, which is 1 bar. And for the liquid streams, we can see that the ethane is a little bit higher than ethylene, and this kind of value is what we need. And we're focusing on the temperature and pressure change. The temperature is about 15.34 degrees Celsius and the pressure is 25352.08 mmHg. And the heat absorbed for this distillation column is about 63.5 kilowatt. And for the next is C2 splitter 2, the same as the other one before, but uh, we need to get this unit because we have to achieve the target purity, which is 99.9%. For the inlet temperature is negative 8.26 degrees Celsius and the pressure is 750 mmHg. And for the outlet that we need is negative 35 degrees Celsius and the pressure is 750 mmHg. So for the heat release, which is 597 kilowatt. So for the condenser, we need to change from the gas to the liquid. So for the temperature inlet is negative 35 degrees Celsius and for the temperature outlet is negative 120 degrees Celsius. And for the Q is a little bit higher from the others, which is negative 2.12 in the power of 6 kilowatt.
So we have just completed all the units for the ethylene production. Now moving on to the costing of our ethylene production. So we will start with the capital cost. So capital cost includes all the equipments and also the ISBL, OSBL and so on. So the total investment required for the ethylene production is around 8,726,086.64 cents.
So next is operating cost. Operating costs include the raw material cost and utility cost. For the raw material cost, the total is for natural gas. The total is 5.74, and the amine for 16648, and the total cost for all the raw materials and utility operating costs is 5.74 exponent 40.
Okay, for the sales expenses, which is what we do for the promotion, advertising, commission, and sales person salaries and wages. So this kind of the sales expenses we need to do by the person or unit and cost per person and unit and the total cost in RM. So what we get in the total expenses is 65,552 ringgit 40 cent.
So now we'll look at the cash flow. Cash flow is divided into two cash flows, which is cash flow with capital cost and cash flow without capital cost. So cash flow with the capital cost, which includes the initial capital cost that you already calculated previously, which is 8,726,086.64 cents. So this will be our cumulative cash flow for the 20 years. And it will end up with 7.06.64 to the power of 16,000 ringgit for 20 years. So this will be our graph where for the first 2 years there will be no cumulative cash flow because we couldn't see any profit there, and then the profit increases tremendously for the following years till 20 years. So this would be our cash flow without capital cost, which means there is no investment, and we will just start with the sales of the ethylene, and the cumulative cash flow for 20 years will be 1.19 to the power of 16 ringgit Malaysia, and this would be the graph for the cash flow without capital cost, where the graph increases according to the year.
So for the conclusion, by feeding 1,000 1 million ton per year of sweet natural gas, our company can produce 395,768.172 ton per year of ethylene with a purity of 99.96% and with the profit of 1.13 to the power of 16 for 20 years.
So, for the recommendation for future, we did not consider on what to do with our waste and filtered impurities. The amount of this waste should be given attention and method to handle it for safety of environment. The second one is the other product, which is ethane, can be sold as a side product for which are in high demand. This in turn will increase the revenue of our company, for which can be used for our operating process to cover the cost. So that's all from us. Thank
Thank
you.
you.
Bye.